In this lesson, we will be going over graphing slope-intercept form. As a little review of slope-intercept form, you might recall it by its formulaic name, y equals mx plus b, where m represents the slope of the function. It also represents what is known as the rise over the run, and it is also the y1 minus y2 over x1 minus x2, or if you want to go into more physics terms, it is the delta y, the change in y, over the delta x, the change in x. Slope has a lot of different interpretations based upon who's presenting it and what they're talking about. But lucky for us, the b value, that kind of only has one interpretation, which is it is the y-intercept of the function. That is to say, where is the function going to intercept the y-axis. So in my example, I have y equals 3 over 2x plus 4. Now, even though we're reading this from left to right, and 3 over 2 does come first, for slope-intercept form, we actually use the y-intercept, the b value. That's the first thing we actually use when graphing this function. Since the y-intercept is positive 4, because it is a plus 4, that means on our graph, which I have off to the right, we are going to go up 1, 2, 3, 4 units, and that's going to represent the location where the line we're going to graph is going to intersect the y-axis, right here. Now that we have the y-intercept, now we can utilize the slope. The slope is positive 3 over 2. So keep in mind the top number is positive, the bottom number is positive. That is going to tell us how we are going to change. The top number tells you how the y value is going to change. The bottom is going to tell you how the x value is going to change. That's why earlier I said it was the rise over the run, or the change in y over the change in x. So since the top number is a positive 3, from our y-intercept, from this dot that we got from the from the red 4, we are going to be going up 1, 2, 3 units. Now if this was a negative 3, we would have gone down 1, 2, 3 units. So we go up 1, 2, 3, and now we're going to apply the x value. That is the denominator of the fraction. Since this is a positive 2, we are going to go right 2. If that was a negative 2, we would have gone left 2. So we have gone up 1, 2, 3, and we have gone right 1, 2. This is going to create a second coordinate. Now if we wanted to, we could repeat that pattern again, going up 1, 2, 3, and right 1, 2, and we can create another dot. This pattern also works in reverse. You can go down 3 and left 2, down 3 and left 2, and we can generate more dots by going down another 1, 2, 3, and left 2, down 3, left 2, down 3, left 2, down 3, left 2, and you can start to see that all these dots that I am creating form a straight line, aka what we call in mathematics a linear function. All linear functions are equations that make straight line graphs. So here are a bunch of other equations. They're all linear functions, and we're going to graph each and every one of them. For problem number 1, the red function, I notice that my y-intercept is negative 4, and my slope is positive 5 over 2. So I'm going to start by going to negative 4 on my graph. 1, 2, 3, 4, which is right here. And then my slope is positive 5 over 2. So I'm going to go up 5, right 2. Up 1, 2, 3, 4, 5, right 2. I could also, for my original dot, go down 1, 2, 3, 4, 5, and left 2. All those dots gather together to form a linear graph, a straight line graph. For the next problem, problem number 2, my y-intercept is going to be positive 1, and my slope is negative 3. Now notice that it's a little bit different than my first problem. My first problem had 5 over 2. It had a number to represent how I'm going to move in the y direction and a number on how I'm going to move in the x direction. That's why I went up 5 and right 2. This is not a fraction. In fact, this might be the only time that I can hear an Algebra 2 student say that they kind of wish a fraction was around. But do realize negative 3 is the exact same number as negative 3 over positive 1. So if the slope is not written as a fraction, you can just convert it into a fraction by writing it being over 1. So the slope is negative 3 over positive 1. Now I have the two pieces of information necessary to draw the graph. Y-intercept is positive 1. Slope is negative 3 over positive 1. So I'm going to go down 1, 2, 3, and right 1. I can go down another 3 and right 1, down another 3 and right 1. We could have also gone from the original dot up 3, left 1, up 3, left 1. And this would form our linear function as follows. Problem number 3 also has a little bit of a curve, a little bit of a twist to it. So my y-intercept is 6. And now there is no number written in front of the x value. Now it's important to note, a lot of students tend to default to thinking like, oh, there's no number, so that means the number is 0. That is not true, because in problems 1 and 2, it is the number in front of the x times the x value. This is 5 over 2 times x. This is negative 3 times x. We are multiplying these two values together. If this was in fact going to be a 0, I would have 0 times x. And no matter what x is, 0 times x is always 0. So this would just turn into 0. So the number in front of the x, the leading coefficient, cannot be 0. Otherwise, the x would just disappear. The number that is actually in front of the x, the slope in this case, is going to be a 1. This is 1 times x, which again is 1 over 1 if you want to write it as a fraction. And now we have enough information to graph this. My y-intercept is 6. 1, 2, 3, 4, 5, 6 is right here. And my slope is positive 1 over positive 1. So we're going to go up 1, right 1, up 1, right 1, up 1, right 1. Could also go down 1, left 1, down 1, left 1, down 1, left 1. And this is the linear function for problem number 3. Problem 4 offers its own unique issues because problems 1, 2, and 3 were all written in the format that we like. Y equals mx plus b, y equals mx plus b, y equals mx plus b. However, problem number 4, kind of got a little scooted over. Problem number 4, it's not written in y equals mx plus b. It's not written in slope-intercept form. So my first issue is I actually need to algebraically manipulate problem number 4 so that's in the format that I like. Now the form that I like, y equals mx plus b, the thing that makes it unique is the y value is isolated on one side of the equal sign. It is by itself. It's not y plus 1 on one side of the equal sign. It's not 2 times y. It's just y equals. So when I look at my problem, I have 2y plus 5. The thing I don't like is that there's a 2 in front of the y and a plus 5 next to the y as well. I need to get rid of both of these. It is recommended that you get rid of addition and subtraction first, and while we can get rid of the 2, it tends to get a little messy if you try and get rid of multiplication and division first. So let's get rid of the plus 5. In order to get rid of the plus 5, I have to subtract 5, because positive 5 and negative 5 would eliminate. They just turn to 0. But I can't just subtract 5 from one side of the equal sign. That makes the equation off balance. If I want that to happen, I need to also subtract 5 to the other side. Now it just so happens to occur that this 5 and this 5 will also cancel. It is not given that this has to be a 5. This could have been like a plus 2, in which case this would turn into negative 3. But in this instance, the 5 actually cancels on both sides, leaving us with 2y is equal to negative 7x. I now need to get rid of the 2 in front of the y. It is 2 times y. To get rid of multiplication, we do division. because 2 divided by 2 is 1, leaving us with y is equal to negative 7 over 2x. So let's state our y-intercept and our slope now. Our y-intercept is the number that we are adding at the end of the equation. We don't have anything being added at the end of the equation. Therefore, this is the same thing as adding nothing. So our y-intercept is 0. Then we look at our slope. The slope is the number in front of the x, which is negative 7 over 2. That tells us how the x and y values are going to change. So my y-intercept is 0. And then from there, I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and right 2. We could also go up 7, 1, 2, 3, 4, 5, 6, 7, and left 2 to get another dot. And this would form the graph of our linear function for the purple equation. The final thing we need to be prepared to do is what happens if I give you the y-intercept and I give you the slope. Can we generate the graph and can we write the equation? So in the previous problems I gave you the equation, we determined the y-intercept and slope, and then we graphed. Here I'm starting off somewhere different, but we're still generating the same kind of stuff. So problem number 1, I'm going to do the graph then the equation. So the y-intercept for problem number 1 is negative 5. So I'm going to go down 1, 2, 3, 4, 5. That's right here. And then our slope is 3 over 2. So from my red dot, I can go up 1, 2, 3, and right 1, 2. If I wanted to, I could generate another dot by applying the slope again, going up 1, 2, 3, and right 2. Up 1, 2, 3, right 2. I could also, from the red dot, go in the reverse order, so go down 3 and left 2. And this would be enough to generate my linear function. The last thing is I want to set up an equation, a y equals mx plus b equation. So this is going to be y equals my slope, which says it's 3 over 2, so 3 over 2, times my x value, plus my y-intercept. Now we can write this in one of two ways. We can go plus negative 5. That's okay, that works. But we don't really like adding negatives. It seems like we're writing too many symbols. So what you will often find mathematicians doing is instead writing minus 5. And there's the equation that matches our graph, that matches the information we started with. For problem number 2, I'm going to do the same thing. I'm just going to do it in a slightly reverse order. I'm going to start by writing the equation. So I'm going to get y equals my slope, which is negative 3, times the x value plus my y-intercept, so it'll be plus 8. So now I have my equation. So let's jump to the graph. My y-intercept is 8, which takes me to right here. My slope is negative 3, which I could write as negative 3 over 1. So that tells me to go down 1, 2, 3, and right 1. I can also go down 3, right 1 again, down 3, right 1 again, and I can do it over and over and over. The more dots I have, the more accurate my graph is going to be. And here we have finished problem number 2.